Alright, welcome to Chemistry B, Unit 7, Acids, Bases, and Salts. Oh my, this is day 4. We're going to talk about strengths of acids and bases today, so let's get started. We classify acids and bases as strong or weak, depending on to what extent they will ionize in water. Now what does that mean? Well, to what extent they will lose or gain an electron in aqueous solution or in water. All right? If it is a strong acid, that we say that with strong acids they will completely ionize in aqueous solutions. That means everything, it will completely ionize. So let's take a look at this strong acid right here. We have hydrochloric acid, HCl, plus H2O produces H3O plus, which is hydronium, the hydronium ion, H3O plus, and chlorine ion, so chloride if you will. All right, and this is a complete ionization. Why? Because all the reactants make new products. As you can see over here on the right hand side, we do not have a partial product. You will see that later on when we start talking about weak acids. We will take care of that here in just a little bit. But what you see is HCl produces H3O positive and a chlorine. We don't get any remnants of hydrochloric acid at all. Okay? So because of that, H3O positive is very high because the acid completely dissociates in water. Alright, so what is a weak acid? Weak acids only ionize slightly in aqueous solutions. Example, CH3COOH plus H2O produces H3O aqueous plus CHCOO negative. So, up here, when we talk about strong acids, you see HCl plus H2O makes H3O plus Cl. There is no remnants of anything that somewhat resembles hydrochloric acid. But when you see a weak acid and you see what takes place, the ionization is only slight, and we still see remnants of the original reactant right here. CH3COO, ionizing goes on, this H goes to the hydronium, to the H2O, and attaches to there, and we have ethonate ion. So it looks like, so you can see some similarities there. That's the easiest way. The ionization of the ethanoic acid is not complete. Okay, we lost the hydrogen. All right. Therefore, the H3O is very low because the acid, for the most part, doesn't dissociate. And, you'll see that on page 606 with the figure 19.16. All right, and so mathematically we can compare this and we can quantify this. We're not going to get into the math of this, but it's something that we need to be aware of. The ratio of the concentration of the dissociated form of an acid compared to the concentration of the undissociated form. The stronger the acid, the larger the Ka value. All right? The value will tell you how much has dissociated or ionized. Now with strong bases, they dissociate completely. So with strong acids and strong bases, dissociation or ionization is complete. In the case of acids, it's ionizing. In the case of a strong base, it's complete dissociation into metal ions and hydroxide ions in aqueous solution. Our example would be a calcium hydroxide compound. All right. Weak bases will react with water to form the hydroxide ion and the conjugate acid of the base. So here we have ammonia, a weak acid, a weak base, excuse me, plus water. It turns into ammonium ion and a hydroxide ion, OH negative. All right, conjugate acid of the base. Just like acid dissociation constant, we have a base dissociation constant. This is a ratio of the conjugate acid times the concentration of the hydroxide ion to the concentration of the base. Okay, mathematical way to figure out what that is. So the smaller the Kb, the weaker the base. Okay? Alright, so just like the acid dissociation constant, we have the base dissociation constant, and that is Kb. The smaller the Kb, the weaker the base. Now we're going to switch to difference between concentration versus strength. Most people think that something that is concentrated must be strong, and something that is strong has to be concentrated because of the way that we use household cleaners and the idea of concentration of orange juice when we make it during the frozen orange juice and all that stuff. Well, it's totally different when we start dealing with acids and bases. They are not the same, okay? Obviously they're not the same. I just told you that. So, concentrated and dilute is basically the same thing. Concentrated tells you how much of an acid or a base is dissolved in the solution, and that is the number of moles of the acid base in a given volume. So how much of that acid or base is dissolved in the solution is concentrated. Strong and weak refer to the extent that dissociation or ionization takes place. Okay? How many particles will ionize or dissociate into ions? That is the difference. Concentrated is how much of an acid or base is in the solution, and strong or weak refers to the extent that ionization takes place in the acid or dissociation takes place with the base.